Okay, so we're doing chapter 9, problem 27. So it says rain is falling at the rate of 5 centimeters per hour and accumulates in a pan. If the raindrops hit at 8 meters per second, estimate the force on the bottom of a 1 square meter pan due to the impacting rain, which does not rebound. And it also says water has a mass of 1,000 kilograms per square meter. Okay, so if the rain does not rebound, then we know that the final speed is 0 of the rain. So we can find the average force as the impulse or change in momentum over the time of contact here. So we can write this as n v final minus n v initial over delta t, but we just said v final equals 0. So this is the same as negative n v initial over delta t. Okay. So now what we can do is we can write the mass in terms of the volume and density. And this becomes the density times the volume times the initial speed over delta t. Well, we can also write the volume as the surface area times the height. So this becomes density times the surface area times the height of the water times the initial velocity all over delta t. And now, at this point, we can start calculating this. So we get the average force here. And this is given as the density, which is 1 times 10 to the 3 kilograms per cubic meter. Our area is 1 square meter. Our height, how are we going to do the height? So the height is given by 5 centimeters per hour. Okay, so what we're going to do here is 5 times 10 to the negative 2 meters. This is divided by per 1 hour. And we're going to convert this hour to seconds. To do that, we multiply by 3,600 seconds per 1 hour. So these will cancel out. And the last thing we need is the initial velocity. And that was 8 meters per second. So this delta t here was given by our rate of the rain accumulating, right? Because we were needing a height over delta t. And what we got right here is how much height accumulates in an hour. So what we did is we have the height over the time it takes an hour, and that is our h over delta t. Okay, just want to explain that a little bit more. And now we can plug stuff in. So if we plug all this in our calculator, we just get the average force out, and it's all in SI units, so we know our answer is going to be in newtons. And we get out an average force of 0.11 newtons. Cool.